Hey dudes, we are checking out an area of triangles with a little trig swing. I hope you're comfortable with the area being 1/2 base times height, with the height being a perpendicular from the base that goes to the other vertex of the triangle. That works well with a right triangle because you can see that if you take base times this height, you get the area of the rectangle, but you only have half of the rectangle, so that's what this half is about. It even works if you have not a perfect right triangle, because you have only half of this piece of the rectangle and only half of this piece of the rectangle. You still have base times height, but only have a half of it, half here and half here. It gets a little more convoluted to visualize when you have a different triangle with a height outside of the body of the triangle, but it still works. So we're going to derive a trig-based equation for this because sometimes we can't measure all the sides. Sometimes we want to use an angle and some sides. So that's where we're going right now. If you're not interested in the derivation, fast forward, great. But I think it's interesting. So if you're looking at this, it's easy to measure A sometimes, but we can't always measure H, or it's a little harder to. So I want to find an expression for H. Well, if we knew this angle C, if we took like this triangle, let's build it outside of here, like that. If this is C and this hypotenuse we'll call B, and this is H, we have a relationship that says, well, the sine of C, there's a ratio that talks about this height over the hypotenuse, the opposite over hypotenuse, so sine is H over B, right? Great. If you rearrange that, you get height is B sine of C. You multiply the B over. Cool. Not a big deal. If you do the same thing for, I want to show that this is an expression for H. Just B sine of C always works for H. So let's do it with a messed up triangle like this, with the height outside. We still want to show that the height is B sine of C. So if you're talking about this angle is C, then this angle on the other side, because this is a straight line and this is a ray, this angle will be 180 minus C. So we can still say that sine of this angle is sine of 180 minus C, whatever that is, should be opposite over hypotenuse, H over B. Right? They should equal the same thing. Okay, so therefore height is B times the sine of 180 minus C, whatever that is. If you think about this on a unit circle, if this is C, right, the sine will be something. In this case, I don't know, let's call it half, right? If you look at 180 minus C, here's 180. 180 minus C is going to be here. It's going to have the same sine. It's going to be the same height above the x-axis. So really, angle C, so angle C is going to be equivalent to the angle 180 minus C. They're the same thing. So really, we can replace 180 minus C with, oh, there's our butt. We can replace 180 minus C with just sine of C. So really, height is just, scratch this out, it's just B sine C. Okay, fine. So we want to plug that into this equation, 1/2 base times height. We have a new equation for height, a new expression. So the area is 1/2 A B sine C. Cool. And so let's try that out. Let's use it. So here's our equation, 1/2 A B sine C. And you'll notice that A and B, this is A, this is little a, because it's across from the vertex A, right? This is A, so it's across from it, has to be A. And this is C, so this has to be C, right? And so this is angle B. These don't have to be exactly the same names, but you should know that these two, if you have a triangle A, B, and C, this little a is going to be over here, little b is going to be over here, and C is the angle in between them. So it doesn't matter how you set them up. These are two sides that are next to each other, and this is the angle that's between them, always, right? Regardless of what they're named. So I know this one's called B, and that might mess you up, but this is just side angle between them. So let's try that out. So let's plug in what we know. I know that, oh yeah, here we go. I just swapped this out for you. So you could say A and C and the angle between them, fine. This is a half, one side is 15, the other side's 11, and sine of 28. Make sure your calculator's in the right mode. It's in degrees rather than radians, and when you crunch the numbers, you should get 38.7. Cool, not a big deal. This is a big deal. Not your trig books, but there's a little fussy bit in here, and that's when you're trying to find the angle between two sides. So here's a triangle with length 6 and 8. It has a certain area, so we're given the area. What are the angles? Or what is the angle? And if you plug it all in, you say, hey, look, I know 8 should be this, 6 should be this. They give me the area of 12. So all I'm missing is sine C. Easy, right? So you start throwing things in there. You crunch this side up. Have the same thing written twice. And so when you clean this up, you get sine C equals a half. And therefore, you get C should be the inverse sine of a half. And if you just throw it in your calculator, it spits out 30 at you. Sweet. But that's not, we're not done, right? That's not the whole story. That you're only half right. There's another triangle in here whose sine is a half, right? And also this triangle has an area of 12 units too, right? You could try it out, right? The area is one half AB sine of 150. And if you throw that in your calculator, you'll get 12 also, right? This is the case because 150 has the same sign as 30. Right? If you look at, here's 30, here's the sine of 30. Over here at 150, you have the same sign because they're at the same height. All right, so you have to be careful about that. When you're at this step, going from here to here, depending on the parameters, there are various angles that work for it. So just think about the unit circle and make sure you found all the pieces. All right, let's take that idea and try it out here. We've got a length, and an area. Determine the two possible angles. They were nice and told you that there's two possible. You won't always know that there are two possible, but when you're talking about areas of triangles and finding angles, there will be multiple possible solutions, so just be careful of them. So I think in the first one, you can plug in half and 10 and 11, right? And you find sine of theta as 50 over 55 when you clean this side up. And then if you take the inverse sine, you end up with this. If you take the inverse sine, you get 65.4, and that's fine. That works for this one. But the other one is always going to be 180 minus that, right? So the other angle is always 180 minus that piece, which is 114.6. So there's that other solution set. Cool. So find your angle, take that angle and say 180 minus that, and that gives you your other angle. Neat. Neat. I'll see you in class. Bye.